journalist in New York. One of the speakers earlier said that people had evolved over hundreds of millions of years to make rational choices. And I think it might be more precise to say that collections of genes have evolved over hundreds of millions of years to make optimum choices, and that those optimum choices for collections of genes might involve irrational choices or variants from rational choices by individuals bearing various portions of those collections of genes. I wonder how the speakers in any way feel they can adapt the rational choice model to speak more broadly to the collections of genes. And in particular, are there any particular cultural, ethological, or other ways of grouping human behavior so that you can see variance in a broad way across those cultures or groups in the way decisions are made?
Anybody wants to tackle that question?
Yes, I really thought about that.
I assume you're thinking of Richard Dawkins' powerful ideas about the selection occurring not just at the level of species, as Darwin had originally proposed in the 1860s, but occurring at the level of individual genes. And of course, we now know that selection occurs not just at the level of individual genes and whole species, but gene clusters. The evolution of data now about the HAP maps and stuff like that seem to indicate that multi-gene loci evolve together. I spoke too quickly when I said that. Selection is definitely occurring at many levels, for sure. As a back-of-the-envelope model, we could take Darwin's and think about selection at the level of the species. It is certainly not the only level at which this selection occurs. And one thing that's striking about this is that some behaviors which appear irrational, when we think about what people tell us verbally they want, I mean, this is natural for an analyst, I assume, make perfect sense when we look more broadly either at the individual's welfare or look at a species groups of behavior. Some of them won't explain easily this way. So the idea I want to get across is rationality in the economic sense is about maximizing utility function. What goes in the utility function is a little underspecified. And one of the things that we might begin to think about when we think about utility functions is our evolutionary heritage. That's sort of the point I wanted to push. And I want to back away from selection at any one particular level, whether at the meme level, the DEEM level, the individual gene level, the HapMap level. All of those things are going on, of course.
Are there any experiments which show variation across large populations of these kinds of rational decisions?
There's a great experiment that's unpublished by Reed Montague's group at Baylor College of Medicine. And in this experiment, Reed has his subjects play what looks loosely like a game. For those of you who grew up in psychology departments 20 years ago, what they're actually doing is an experiment of Richard Herrnstein's, of the Harvard psychologist Richard Herrnstein's. They're picking between two levers. The levers pay off money with probability distributions that are a little complicated. It turns out that there are two good solutions to this. One solution is to half the time push the left lever and half the time push the right lever, basically in random order. There is a better solution, but it's hard to find. What you have to do is push the left lever 9 times for every 1 time you push the right lever. The reason this is hard to find is that all the intermediate ratios stink. And it turns out that only half of Reed's subjects find this better solution. Half do and half don't, just odd. So they drew blood from these people, and they genotyped their dopamine receptors. And it turns out that all of the people that find the best solution have a particular isoform of the dopamine D5, if I remember right, subtype of receptor gene. And this particular isoform seems to be associated with propensity towards risky behavior.
Okay.
The intellectual power that's represented at the table